Hello dear student, welcome back to Medchem Companion channel. Now we will discuss some of the example based on the Fischer projection formula in which we have to assign the exact configuration of the chiral carbon. So here again I have taken the example of 2-hydroxypropionic acid. This is 2-hydroxypropionic acid. Both these structure are of 2-hydroxypropionic acid. Now the question is, we have to find out the configuration of this chiral carbon in both this molecule, and we have to assign the configuration, whether it is this carbon is R or S, having R configuration or S configuration. So let us find out the exact configuration. First of all, according to SIP rule, we have to set the priority order amongst the 4 different groups which are attached directly to the chiral carbon. So in this molecule, this is the chiral carbon and we have 4 different functional groups. Now we will assign this to first priority to this hydroxyl group, then second to this carbon, then third to this, and last lowest priority is given to this hydrogen. How we have given this priority, it is already discussed in the previous lecture. So those who haven't seen those previous lecture, they should first see those lecture and then come to this 5th lecture of stereochemistry. Otherwise you will not be able to understand the exact concept. So I have already set the priority. Now after setting the priority, we move our arrow from first priority functional group to third priority functional group, leaving the lowest priority group as such. So here 1, 2, 3, these are the 3 groups and this is the 4th one. So we have to omit this 4th one and we have to draw an arrow from first to second and from second to third, and you will see that this arrow goes from first, second to third in a clockwise direction. So first, for this molecule, direction of arrow is clockwise. So if direction of arrow is clockwise, that we have already discussed in previous lecture, that if direction is clockwise, then configuration of this chiral carbon is what? R. But this is not the final configuration. We need to assess some more point before assigning the final configuration. So what is the third point? Position of the lowest priority group. Position of the lowest priority group is what? Hydrogen, because it has the least priority, 4th. So what is the position of this lowest priority group? Horizontal. It is hydrogen is placed in horizontal position with respect to this chiral carbon. So if position of lowest priority group is horizontal, then here comes the main point. If position of lowest priority group, lowest priority group is in horizontal position, then configuration of carbon flipped. Configuration of the carbon flipped. What is the meaning of this? Configuration of carbon is flipped. Configuration of carbon is what? R according to direction, clockwise or anti-clockwise. But if lowest priority group is on horizontal position, then the configuration of carbon flipped. So this configuration R become S. This R become what? S. So here in this molecule, the exact configuration of this carbon is what? S. What? S. So how we can name this molecule? S2-hydroxy propionic acid. This is the actual name, 2-hydroxy propionic acid. Now let's move on to this next molecule. Here again, this is the chiral carbon. So first we have to set the priority. So which functional group should be given first priority? This hydroxy. Why? Because here oxygen, the highest atomic number atom, is directly attached to the carbon. Now after that, this carbon should get the second priority. Now after this methyl carbon should get the third priority, and finally the hydrogen, the least priority group, should be given fourth priority. Now again, after setting the priority, we should draw arrow from first priority group to third priority group, leaving behind the fourth one. So this is your first priority group. So first to second, and from second to third. So in which direction it is moving? It is moving in clockwise direction. So again, direction of arrow, which one? Clockwise. So if direction of arrow is clockwise, then configuration of chiral carbon, configuration of this chiral carbon are according to SIP rule. Now position of the lowest priority group, lowest priority group is what? Hydrogen. So what is the position? Position of lowest priority group is vertical. Position of lowest priority group is what? Vertical. So what is the final configuration then? So if position of lowest priority group is vertical, then configuration of chiral carbon should be retained. Retained matlab as such. The configuration of chiral should remain as such. So what is the original configuration given? R. So this carbon has which configuration? R configuration. So what is the name of this molecule then? So this is actually R 2-hydroxy propionic acid. 2-hydroxy propionic acid. Now I want to ask a question to you, to all of you. If this is S2-hydroxy propionic acid and this is R2-hydroxy propionic acid, then what is the relationship between these two molecules? So in first lecture of stereochemistry we have discussed, if configuration of chiral carbon changes from S to R and R to S, means both molecules are what? Enantiomer. So that's why these two molecules are what? These two molecules are enantiomer of each other. These two molecules are what? Enantiomers. So I hope you understand the concept. We will see more example in the later section or later lecture. Thank you.